Hi, this is Rajnikant Mishra. Today we are going to discuss sine and cosine formula of geometry. These two most important geometry and trigonometry formulas are used to describe the relationship between sides and angles of a triangle. But before starting the proof of these two formulas, let's take a look at an important problem discussed in the previous video. In this question, ABC is a triangle. AP, BQ, CR are the medians of this triangle. It means P, Q and R are the midpoints of the respective sides. The length of medians are given. AP is equal to 6 cm, BQ is equal to 3 cm, CR is equal to 5 cm. Then the first question is, find the area of triangle ABC. The second question is, find AB square plus BC square plus CA square, means the sum of the squares of the sides of this triangle. If you want the solution of this question, then check out the link given in the description box. Now, sine formula. Here ABC is a triangle. AD is a perpendicular drawn from vertex A on side BC. The length of BC is equal to A, AB is equal to C, and AC is equal to B. The height of this triangle is H. Then, here in this right angle triangle BDA, angle D is equal to 90 degree. AD perpendicular and AB is hypotenuse. So sine B is equal to perpendicular AD by hypotenuse AB. So sine B is equal to H by C. Similarly, in right angle triangle CDA, sine C is equal to H by B. Here H is equal to C sine B. And here H is equal to B sine C. From equation 1 and 2, C sine B is equal to B sine C, or B by sine B is equal to C by sine C. Now draw BE altitude on AC, where BE is equal to K. Repeat this same process in right angle triangle BEA and BEC. Then we get A by sine A is equal to C by sine C. After comparing both the equations, the final result is A by sine A is equal to B by sine B is equal to C by sine C. Here this formula is known as sine formula. Sine formula is used to find the ratio between the sides. Here A ratio B ratio C is equal to sine A ratio sine B ratio sine C. Here A upon sine A, B upon sine B, C upon sine C is equal to a constant, that is 2R. Here R is the circumradius of this triangle. Here this R is the radius of this circle. And this circle is known as the circumcircle of this triangle ABC, because all the vertices of this triangle ABC lie on the circumference of this circle. In this figure, BD is the diameter of this circle. Means if this radius is R, then BO is equal to OD is equal to R and BD is equal to 2R. Join C to D, then this angle BDC and BAD are equal. Because here BC is a chord. Angles subtended by same chord on the boundary of the same segment of a circle are always equal. Here BD is the diameter, and we know the angle subtended by the diameter on the boundary is always 90 degree. So apply the sine formula in triangle BDC. BC by sine BDC is equal to BD by sine BCD. The angle and the side opposite to it, the angle and the side opposite to it. BC is equal to A. BDC is equal to BAC, means we can write angle BDC as angle A. Here BD is equal to 2R and sine 90 is equal to 1. So A by sine A is equal to 2R. So we can put A by sine A is equal to 2R. Now this is the complete sine formula. Now cosine formula. In triangle ABC, BD is altitude, BD is equal to H, AC is equal to B, AB is equal to C, and BC is equal to A. In right angle triangle BDC, apply Pythagorean theorem. Hypotenuse square is equal to perpendicular square plus base square, means A square is equal to H square plus DC square. Here this DC is equal to AC minus AD. Put AC minus AD in place of DC. Here this AC is equal to B. Now use this formula, x minus y square is equal to x square plus y square minus 2xy. B square plus AD square minus 2 into B into AD. Here this H square plus AD square. H square plus AD square is equal to AB square, means C square, using Pythagorean theorem. H square plus AD square is equal to C square. This is our equation number 1. In right angle triangle ADB, for angle A, this is base, this is perpendicular, and this is your hypotenuse. So cos A is equal to AD by C, base by hypotenuse, or AD is equal to C into cos A. Put this value of AD in this equation. The final result is A square is equal to B square plus C square minus 2BC cos A. Similarly, P square is equal to C square plus A square minus 2CA cos B, and C square is equal to A square plus B square minus 2AB cos C. These are known as cosine formulas. Now in right angle triangle ADB, cos A is equal to AD by AB, which is C, and in right angle triangle BDC, cos C is equal to CD by A, based upon hypotenuse, or AD is equal to C cos A, and CD is equal to A cos C. If you add these two equations, AD plus CD is equal to AC and AC is equal to B, so the result is B is equal to A cos C plus C cos A. Similarly, C is equal to A cos B plus B cos A, and A is equal to C cos B plus B cos C. This is another set of cosine formulas. Now question of the day, in this triangle ABC, A is equal to 60 degree and BC is equal to 6 centimeter. Here you have to find the area of this outer circle, which is known as circumcircle. Here we use the sine formula, according to which A upon sine A is equal to 2R. Here A is 6 centimeter, sine A, sine 60 degree is equal to 2R. Here R is the radius of this circumcircle. We know sine 60 degree is equal to root 3 by 2. 6 into 2 by root 3 is equal to 2R. 2 cancel out. This 6 can be written as 2 into 3 by root 3 is equal to R. Now R is equal to 2 root 3 centimeter. The area of the circle is equal to pi r square. So the area of the circle is 12 pi centimeter square. This is your homework problem. Why the volume of this cone is 1/3 of this cylinder? Here, the base radius and height of cone and cylinder are equal. This problem will be discussed in the next video. If you like this video, hit the like button, share it with your friends, and never forget to subscribe and hit the bell icon so that you will never miss any important update.